Thank you for viewing the Embedded Accessibility Strategies presentation developed by the MAISA Mathematics Leadership Team. This presentation is designed to help teachers, in particular those of students that receive Title I services, notice and make use of the accessibility strategies that have been embedded throughout the MAISA CCSSI mathematics curriculum materials to support student learning. The purpose of Title I is to ensure that all students have a fair, equal, and significant opportunity to obtain a high-quality education and reach, at a minimum, proficiency. While the strategies we will point to in this presentation can be useful for all teachers, they are critical to those who work with students that struggle in one or more areas of mathematics. Unit abstracts and graphic organizers in several grades have been updated to make more visible to teachers the mathematical progressions across grades. These updates are particularly helpful to teachers of students that receive Title I services as they articulate what learning opportunities students should have had in previous grades with respect to a particular topic. By making potential mathematical connections more visible to teachers, they are better equipped to help students make these mathematical connections a strategy to support deeper learning and retention.
These two graphic organizers are from two separate units in third grade focused on multiplication and division. The mathematical ideas in the graphic organizer on the right are clearly related to the ideas in the graphic organizer on the left. However, the ideas in the organizer on the right represent more sophisticated understandings, indicating a progression of learning across a single grade. For example, in Unit 2, students use number lines and arrays to represent multiplication. The area model is noticeably absent from this graphic organizer because students have not studied the concept of area at this point in the year. Between Units 2 and 5, students study area and so are prepared to relate this concept to multiplication operations when they are in a unit later in the school year. Again, that's represented then in the graphic organizer on the right from the later unit. Another difference is that multiplication in Unit 2 does not incorporate the use of place value. This is because students are only working with single-digit multiplication in the introductory unit. However, in Unit 5, students begin multiplying a single-digit number by a multiple of 10, thus bringing in ideas of place value. These progressions, made visible in the graphic organizers, can help teachers be attentive to important mathematical connections and help them plan for increasingly sophisticated mathematical goals throughout the year. Before talking about this particular slide, I'd like to give you a moment to read through it. In the last example, using the graphic organizers, we saw progressions attended to within a grade. In this example, progressions are noted across consecutive grades. Those appear in the abstract to help teachers notice these progressions. Here, the abstract reminds us that 5th grade students have done previous work on fraction, equivalence, and decimal operations. It also points out that students will continue this work, relating it to percents in 6th grade. These cross-grade progressions can help teachers plan, much like what was noted in the previous slide. Further, the use of multiple representations is emphasized in this abstract as a strategy to support student learning. In addition to making visible connections within and across grades, using the graphic organizers and abstracts, we have embedded accessibility strategies into the highlight lessons and formative assessments. At this point, we will begin to address the embedded strategies in these materials. We use the representation stars you see here as a framework to inform updates to these curriculum materials. You will hear us reference the use of multiple representations in upcoming slides as we draw attention to the embedded accessibility strategies. These graphics depict ways in which students engage with and represent mathematical ideas. The star on the right is designed to depict thinking that is algebraic in nature, while the other is more general. In the highlight lessons, students have opportunities to represent their mathematical thinking in ways that make sense to them. Teachers can use student representations to facilitate access to the mathematics and eventually as a strategy to advance their students' thinking. So while these stars are not to indicate that students should represent every problem in 5 different ways, they do suggest to students ways to access the mathematics in a variety of different ways, allowing them to make connections among the representations and allowing teachers to prompt students to a higher depth of knowledge with deeper understanding over time.
Here you can see these are the particular strategies that we are going to discuss throughout the rest of the presentation. Connecting to prior knowledge, multiple entry points, the intentional use of color, questioning, technology, and utilizing student thinking. Earlier, you saw an example of graphic organizers that articulated a progression within a grade, and an example in an abstract highlighting a progression across consecutive grades. In this highlight lesson, explicit connections are made between strategies and experiences students had in elementary school that are relevant to their work with angles in middle school. We work to make connections such as this one visible in these documents, as it can be challenging for teachers to connect to students' prior learning experiences if they are unfamiliar with the learning opportunities in previous grades. When teachers are aware of these kinds of mathematical connections across grade, they can help their students notice and be able to use them in their learning. Here's an example of a student handout that is structured so that students may record their thinking in a variety of ways. While not every task handout is structured as a template to prompt students' use of multiple representations, many of the tasks used in the highlight lessons and formative assessments in these curriculum materials were designed so that students can begin working on them using a strategy that makes sense to them. For example, on this task, some students might begin with the sketch and use that to determine the perimeter. Others may choose a different strategy, for example a table of values, to begin the problem and work out a solution from there. By using these types of tasks, students are able to begin the problem by making sense of the mathematics in whatever way is comfortable for them. With this said, it is important to note that how a student enters a task may not be representative of how the teacher hopes he or she will be thinking about the mathematics by the end of the task, unit, or year. Still, this flexibility allows the student an entry point to the mathematical ideas being learned and provides valuable formative assessment information to the teacher. After seeing which strategy or strategies a student uses, including the correct and incorrect thinking associated with its use, the teacher is equipped to use the student's work to prompt more sophisticated thinking and strategies over the lesson, unit, and/or school year. Color is often used for aesthetic purposes in many classroom situations. However, color is intentionally used here in this highlight lesson to draw teachers' attention to a student misconception and a correct strategy. The common colors between the rectangular diagram and the formula can help students make the connection between these two important representations. This kind of intentional use of color should carry over to the classroom setting to help students make connections between representations of mathematics. Use of color in this manner should also be used to support access and to advance student thinking.
Here we see an excerpt from a highlight lesson once again. The questions listed are questions that focus around the key ideas of the mathematics. For instance, look at the third question. What equation can model the relationships between the lengths you have labeled and the perimeter, and also the lengths you have labeled and the area? This question connects back to the color-coded diagram we just explored on the previous slide. Here you see an app that was developed by the National Council of Teachers of Mathematics and is available for free on their website, illuminations.nctm.org. Many apps from a variety of developers have been included within the resource section of the unit overviews. Additionally, apps may also appear as featured portions of a highlight lesson or formative assessment. These online activities are a way in which students can engage with mathematics using the dynamic nature inherent in many apps to help them make sense of the concepts with which they have struggled in the past. Versions of this app are used across kindergarten and first grade in the MAISA curriculum materials. The units incorporate examples of potential student thinking intended to be used by teachers to open up students' access to the mathematical ideas, as well as be used to deepen, clarify, or extend student understanding. To this end, we have tried to include representations that teachers may be less familiar with given their resources and past learning opportunities. In this example, we see the open number line. So while the open number line is used as a strategy in the lesson, text and graphics have been included to help teachers make sense of the representation and how they might use it to help students reason mathematically. In this case, the focus is on addition. The portion highlighted in yellow simply reminds teachers that having students explain and share their thinking with one another around their use of this strategy and others can support learning of the content. Other ways that student thinking have been included within these materials is through excerpts of student thinking from classrooms. Often the sample student thinking accompanies a formative assessment. In addition to having sample student thinking available to consider and use with students, the templates for the formative assessments often suggest ways teachers might use them. They might prompt a common misconception and/or common student thinking that could be used to advance their students' thinking during a re-engagement activity. In this particular activity, the student's thinking is essentially correct. However, it could be more specific. The inclusion of the question, "How is 360 degrees helpful?" can be used to prompt other students to consider this strategy. Further, the open nature of the question, as well as the inclusion of visual models, support students' explanations, written or oral.
Throughout this video, we have outlined a variety of accessibility strategies that have been embedded in the MAISA CCSSI mathematics materials. In drawing attention to these strategies, we hope that we have helped you to notice and be able to use them as you enact portions of these materials in your classroom. Secondly, you can begin to incorporate these strategies as you plan for and enact lessons using your textbooks and other instructional materials. As we said at the beginning of this presentation, while the accessibility strategies embedded in the units can be useful for all teachers, they are critical to those who work with students that struggle in one or more areas of mathematics. So in closing, the purpose of Title I is to ensure that all children have a fair, equal, and significant opportunity to obtain a high-quality education and reach at a minimum proficiency.